Nithilan,
Yeah, sir.
Yeah, we'll wait for, we'll wait for others. No one has joined.
Yeah, fine, sir.
So in the meanwhile, you take the electrostatic potential and capacitance paper ready. You have it ready.
Yeah, okay, sir.
Yeah.
Sir,
Yeah.
is there any text this week, sir?
No, this week there is no test. I have not yet announced.
Yeah, fine, sir.
Nithilan, do you have any exam tomorrow in school?
What is it?
Do you have any exam in school tomorrow?
Yes, sir. We have a chemistry exam.
Is that the reason no one has joined?
What's that?
Is that the reason no one has joined? Is what I'm asking.
No, sir. It's a small test, sir. A class test, not a big exam.
Okay. Okay. Anyways, we'll get started.
Yeah.
Did you write this test?
Yeah, I wrote it, sir.
So two capacitors, one of capacity C and the other of capacity C by 2 are connected to a V volt battery as shown. They are joining together. The work done in charging fully, the work done in charging both the condensers fully is how much? That is energy stored in this plus energy stored in this. U1 plus U2. So U is equal to U1 plus U2, which implies U is equal to half CV square plus half into C by 2 into V square. So that will give me how much? 3 by 4 CV square. So 3 by 4 CV square is the answer. Okay. Next. Okay. Next. There is a copper plate of thickness B. So copper means it is a conductor. So there is a copper plate of thickness B which is placed inside a parallel plate capacitor of plate distance D and the area A. So what is going to be the capacitance? So capacitance is epsilon naught A divided by d minus t plus t divided by kappa. But kappa for a conductor is how much? Dielectric constant of a conductor is how much? How much is it? Okay. Kappa of a conductor is infinity. It is not defined because it's a dielectric constant. Conductor is not a dielectric. So when you take infinity and substitute it here, you will get epsilon naught A divided by D minus. The thickness is D. So the option is this thing, C. Third, in which of the states shown in the figure is potential energy of an electric dipole maximum? So U is equal to minus PE cos theta. Theta should be equal to 180 degrees for U to be maximum. So theta is equal to 180 in which case? This is the direction of P. This is the direction of E. Answer is C. Is that clear? Fourth, an electric charge of 10 power minus 3 microcoulomb is placed at origin. 2 points A and B are situated at root 2, root 2. It will be 2, 0 and root 2, root 2. The potential difference between the points A and B will be how much? Why? Yes. So this is 2. There is also, sorry, this distance. No. They are not at same distance, are they? Yes, they are. Sorry. So since they both are at the same distance, answer will be 0. Capacity of a parallel plate condenser is 10 microfarad. So C is equal to 10 microfarad. When the distance between the plates is 8 centimeter. If the distance between the plates is reduced to 4 centimeter, what will happen to the capacity? So D dash is equal to 4 centimeters. C dash should be how much? So C is inversely proportional to D, which implies C dash divided by D is equal to D divided by D dash. D is 8 by 4. So it will become 2. C dash should be 20 microfarad. Right? Electric potential and electric potential energy are different quantities. True. For a system of positive charge and point charge, electric potential energy is equal to electric potential. Is it right? If you have a system of positive test charge and and point charge, electric potential energy is equal to electric potential. Is it right? So A is true, but R is false. Correct? If the distance between the plates of a capacitor is halved and the dielectric constant is made 3 times, the capacitance becomes 6 times. See, if the distance is halved, capacitance becomes twice. Yeah, false. see distance decreases, the factor by which distance decreases, capacitance will increase by the same factor. If it becomes half, capacitance will become twice. And there is a dielectric of constant 3 that is there. So capacitance will become 6 times obviously. C is equal to kappa times C dash is equal to kappa times C naught. So it becomes 6 times. So this is true. Capacitance of the capacitor does not depend upon the nature of the material. Capacitance of a capacitor does not depend on the nature of the material of the plates of the capacitor. Yes. Seventh. Oh, seventh answer. Wait. Seventh answer வந்து B ன்னு கொடுத்திருக்கு. Just thinking. Because generally when you actually maybe it is right, because when you talk about the capacitance of a capacitor, right, it basically depends on the material that is being placed. You call it as a paper capacitor depending on what kind of a dielectric is used. But the question is ambiguous because it does not depend upon the nature of the material of the plates. It depends. Because you cannot use dielectric and say it is a capacitor. This one I'll check. Eighth one. When a capacitor is charged by a battery, both plates receive equal charge and magnitude, no matter size of the plates of, no matter sizes of the plates are identical or not. Is it right? Is it right or wrong? Yes. The charge distribution of the plates of a capacitor is in accordance with the charge conservation principle. Yes. So this is also true. But is it the right explanation for A? Distinguish between dielectric and a conductor. So dielectrics are insulated, which do not have free charges to flow among them. So they do not have free charges, whereas conductors have free charges. Dielectric constant of a dielectric is a fixed value, whereas for a conductor it is infinity. 2 points. Figure shows the field lines due to a positive charge. Is the work done by the field in moving small positive charge from Q to P a positive or a negative value? So when Q is moved between points A and B, you mean to say it's a negative value? So UP minus UQ is how much? Q into VP minus VQ. So electric field is in the direction of decreasing potential. So VP is greater than, sorry, UQ minus UP. So VP is greater than VQ. So what can you say? That work done is negative. Yes, you can say the angle between the displacement and the forces in the opposite direction. What is the geometrical shape of equipotential surface due to a single isolated positive charge? Obviously, it's a set of concentric spheres. So calculate the potential difference in energy stored in the capacitor C2. The circuit shown in the figure. Given potential at A is 90. Okay. So grounded means potential is 0. C1 is 20 microfarad. C2 is 30 microfarad. C3 is 15 microfarad. Okay. How to solve this? So Q is equal to CV. C equivalent is how much? 1 by C is equal to 1 by 20, 1 by 30 plus 1 by 15. 20 by 3 or other. $20 by 3 into what is the potential difference? 90. So 600 microcoulomb is the charge on each capacitor. Now you know the charge on this. V is equal to Q divided by C. Q is how much? 600 microcoulomb divided by 20 microfarad. How much is this going to be? 30. Oh, second. Second means 600 by 30. That will be 20 volt. So 30, 20. The remaining thing should be 40. 40 volt. 600 by 15. We will get 40. So answer is 20 volt. Energy you can find, no? U is equal to half CV square. You know half into C is 30 into 10 per. 30 into 10 power minus 6 into V square is 400. 20. 600 into 10 power minus 6. 6 into 10 power minus 4 joule. Minus 3. Engama 200. Half into 30 into 10 power minus 6 into V square. V is 20 volt, no? Up it should be 400. This will go 200. 200 into 6,000, sorry. So 6 into 10 power minus 3 joule is the right answer. That's right. So there is a parallel plate capacitor, each of plate area A and the subplation B between the two plates is charged with charges plus Q and minus Q at the two plates. Reduce the expression for the energy stored. So E is equal to V eவ்வளோ? They want it in terms of Q, no? So energy is half CV square. Half into C is epsilon naught A divided by D into V is how much? E into D square. But what is E? Sigma by 2 epsilon naught. So sigma eவ்வளோ? Q by 2A into epsilon naught into D square போடலாமா? So it will be Q square by A square epsilon naught square into D square. Q square divided by 2A into D. Q by A is sigma, no? So sigma by 2 epsilon naught is due to one plate. There are two plates, no? Sigma by 2 epsilon naught and sigma by 2 epsilon naught. Q square D divided by 2A should actually be the answer. They have done something else. V on it is not even there. So actually what I wrote is the right answer. Because whenever the derivation is asked, right, you should always write it in terms that are given in the question. Copy it. V then, but V question done. Shall I proceed? Give two examples of conservative force: gravitational force and electrostatic force. 15th one, the following arrangement of capacitor, the energy stored in the 6 microfarad capacitor is E. So energy stored here is E. Find the value of the following, the energy stored in the 12 microfarad capacitor. So if I say the potential difference is V here, okay, is there anything missing in the question? V ne eduthukalam. If I take the potential difference here as V dash, here it will be V minus V dash. Okay. Half into 6 into V dash square is equal to E. What is V dash square? E divided by 3. Accepted? So wherever I find V dash square, I'll substitute E by 3, or I can say V dash is root of E by 3. Accepted? Yes or no? Next is energy stored in the 12 microfarad capacitor. So half into 12 into V dash square. 6 into V dash square is E by 3. So it will go 2 times. So 2 times E. So answer here is 2E. Energy stored in the 3 microfarad capacitor. V minus V dash square. For that, I need to find out what is V square. V square conducting. Find the total energy. Because 6 and 12, the equivalent capacitance is 3 here. 12 and 6, what are the equivalent capacitance? 18, no? That 18 is a 3, illa? How is it 6? Okay. We can do it like this. So the equivalent capacitance here is how much? 18. Okay. So on both the capacitors, charge is the same. Q is equal to Q dash. But how will you write charge in terms of capacitance and potential? Q is equal to CV, right? So 18 into V dash is equal to 3 into V minus V dash. So 21 times V dash is equal to 3 times V in Eduthrama. So V dash is also equal to 3V divided by 21 or V divided by 7. But you already know what is V dash. So V dash iduna, appa V dash square will be V square divided by 49. But what is V dash square? We already derived it. E by 3. Adi E by 3. நான் சொல்ற புரியுதா? அப்ப V will be equal to 7 times root E by 3. That is what I am trying to say. அப்ப இங்க என்ன potential இருக்கும்? ஏன் 6? எப்படி 6 times டா? அப்படி எடுத்துக்கலாம் இல்லையா? அப்படி கூட பண்ணிக்கலாம். So half into E into 7 into root E by 3 minus root E by 3 the whole square. அப்ப வெளில வந்து E by 3 வெளில வந்துரும். 3. கரெக்டாடா? So half into 3 into E by 3 into 36. இந்த 3 இந்த 3 போய்டும். இது வந்து it will cancel 18. So 18 times E is the answer. Here it is 18 times E. Only for 3 microfarad. For 3 microfarad it is 18 E. For 6 microfarad it is E. They have already given the question. And for 12 microfarad how much do we get? 2E. So for total energy 2E plus E plus 18E 21E. This is a very, very important problem. I have seen this kind of problems. Now, did you understand what I did? You're copying it. Ready? Define an equipotential surface. Draw equipotential surface in case of a single point charge in constant electric field which is in the z direction. Why the equipotential surface about a single charge or not equidistant? Can electric field exist tangential to an equipotential surface with reason? So answer for the first one, spherical. Second, there is a constant electric field in the z direction. Why the equipotential surface about? Okay. So for that you need to draw the diagram. When you have a constant electric field in z direction, what will be the equipotential surface? It will be a plane sheet. It will be a plane sheet in the xy direction. This is the equipotential surface. Okay, why equipotential surface about a single charge or not equidistant? Okay, So because for a single charge, how do we represent them? As set of concentric circles. When you go as concentric circles, right, the distance between them might vary. No. As you go away, the equipotential surface shape will they'll get closer to each other. Write down the reason, I'll tell you. So they'll become closer because the distance between the equipotential surface goes on increasing with a decrease in the value of electric field. So the distance between the equipotential surface goes on increasing with a decrease in the electric field. Point C. See, if it is tangential, there will be work done in moving the charge from one point to another. If work is done, then it will not be an equipotential surface. Because work done on an equipotential surface is. So two charges, 5 and -3, are 16 centimeter apart. At what points on the line joining the two charges, the electric potential is 0. So it will be closer to which charge? It will be closer to the charge with lesser magnitude. In this case, it is minus. So when you told minus, no, for example, at the question be -5 and +3. So do it, no? What will be the answer? I want the answer. 2 minutes, and do it fast. Sorry? 6 or 10? 6 centimeters from where? On the left or right? So is this how you took it? So here you are saying 6, sir. Is this right? Correct, huh? So 6 centimeter on the right. How did you take the point? One will be outside and one will be inside. No? You will generally not report -6. Minus this side, huh? Okay, that side it is how much? See, this is R, this is R minus A. Okay, so this is 5, this is 3. So 5 by R will be equal to 3 divided by R minus A. So R is 16, no? R, the 16 minus R. 80 is equal to Varun Shada. So R is equal to 10 centimeters. So 10 centimeters from here. So it should be 6 only, no? 6 on the left. That is right. this side here. Okay, I'll call this as R dash. This is R dash minus A. So 5 divided by R dash is equal to 3 divided by R dash minus A. That is R dash minus 16. So 5 R dash minus 80 is equal to 3 R dash. So 2 R dash is equal to you will get 40. Five by 16 plus x is equal to, it is 3 by x. So 5x will be equal to 48 plus 3x. So 2x is equal to sub x. 2x is equal to 48 up x on the 24 hour. So this will be 24. 24 plus 16 is still 40. So I have reported the answer with respect to 5. So with respect to 5, the 2 points are at a distance of 10 centimeter and 40 centimeter on the right of it. That's the answer. The point where the potential is 0 means the work done by both the charges put together is 0. Together is 0. The total potential is 0 means sum of the potential due to point A and sum of the potential due to the charge at point A and sum of the potential due to the charge at point B put together should be 0. In the middle, it will happen only if both the charges are of equal magnitude. Equal magnitude. Equal sign, you will not get potential 0. You won't try and see. Only electric field will be 0, potential 0. I've told this when I solved this problem. If at all you have a problem where on the line joining both the charges, if you're asked to calculate the point where the total potential is 0, the first preliminary condition is both the charges should be of opposite sign. I wrote it as 5 by R is equal to 3 divided by 16 minus R because it is, what is the potential due to point A? KQ divided by R. What is the potential due to point B? Minus KQ dash divided by A minus R. Why is this minus sign coming? Because it's a negative charge. For potential, you take the sign of the charge into consideration. For electric field, you will not take because it is a vector quantity and direction will take care of the sign. Whereas when you're dealing with scalar quantities, you need to go with the concept of negative sign. That is why in the third problem also, if you see, U is equal to, I was very particular that it is minus P cos theta. I didn't write it as P cos theta and B. I was concerned about minus sign. Two positive charges with equal magnitude. 0. How can sum of two positive values be 0? Electric field is 0. This is 2. This is also 2. The midpoint is, let's say, 5 and 5. For example, our potential due to A another 2K by R, 2K by 5 plus 2K by 5. This is positive, this is positive. How can I write it? Potential in the direction. It's a scalar quantity. Electric, I am stressing from the beginning. Electric field is 0. This electric field and this electric field will get cancelled, whereas potential will get cancelled only if the charges are of opposite nature. Else the question is meaningless. If at all they give you two positive charge and ask you to find a point on the line where the total potential is 0, forget about it. You will never get it. So the option on the invalid point of the answer. Question is invalid. So yeah. 18th one. If two or more capacitors are connected, the overall effect of the single capacitor having the sum of. Okay. having the sum total of the plate spacing of the individual capacitor. If two or more capacitors are connected parallel, the overall effect is that of a single equivalent capacitor having the sum total of the plate areas of the individual capacitors. Okay. Capacity can be increased by connecting capacitors in parallel. Three capacitors having potential capacitance 2, 4, and 6 are connected in parallel. Equivalent is 12. When capacitors are connected in series, dash remains the same charge. The capacitors of a parallel plate capacitor are 10 centimeter apart, have an equal area of 2 centimeters square. The charge on the plate is 8.85 to 10 power minus 10. The electric field is E is equal to sigma by epsilon naught. Sigma Q by A. So Q is 8.85 to 10 power minus 10 divided by area is 2 into epsilon naught is 8.85 to 10 power minus 12. So this will become 10 power 2 divided by 2, that is 100 by 2, which is 50. Irka 50. Okay, the electric field at a point between the plates of the capacitor will be 0. No. Outside the plates of the capacitor will be 0. So we need not solve this section. Had they given it as 50 Newton per coulomb, that would have also been, so more than one option would have been right. Okay. So 4 10 farad capacitors, 10 farad capacitors are connected in series. Calculate the equivalent resistance. So 10 by 4, 2.5. That's it. Huh? Derive an expression for the electric potential due to an electric dipole at an axial point. So how much is it? KQ by R. So you will take 2 points, Lada. One like this, one like this. Electric field, electric potential. Don't do that. Direct up. So distances are always measured from the. That's how it's an individual derivation. If electric field is given, I know if you integrate it, you're going to get potential. But CBSE lo othukomata. If you want marks, do that. This R, there's A, there's R minus A, there's R plus A. So KQ divided by R plus A minus KQ divided by R minus A. So KQ into 2R divided by R square minus A square. Sorry, 2A. So KP divided by R square will be the answer. Actually, in this case, it will be minus Kp divided by R square. Because you're getting minus 2. It's closer to the negative charge, that is why it is minus Kp by R square. Had it been closer to the positive charge, you would have got Kp divided by R square. Depict the equipotential surface due to an electric dipole. You know that already, right? So due to an electric dipole, what will happen? They will not touch each other. So in between would be the equipotential surface. This is there in the textbook. That's it. Right. I hope we have covered all kinds of problems in this. Is it clear? Yeah. So this is over. Next we have the current electricity part of the moving charges. We'll discuss those papers, then we'll go to the next module. Next module, 8 chapters coming. So any other doubt, any other theory? Moving charges and magnetism. Magnetism is this is not required. 5th chapter. Electromagnetic induction is 6, alternating current is 7. Yeah, apart from this, any other doubt in this chapter? Is it clear? Everybody wrote the test. What your marks? Okay, this paper is already corrected. This test tool. The score is in front of me. 26, 28, 23. So இது பாருங்க அடுத்தது வந்து Electricity we'll discuss. So if there are any doubts, have a note. Anything else? Should we wind up then? Repeat the question again. On the line joining. So you have a positive charge and a negative charge. You want a null point at which place? That's how it works. Yeah, always. Because if you take a point P here, then the distances should be in such a way that, yeah, it can be. It can. So positive charge of 5, negative charge of 3. Is this what you're saying? So if I take a point P here, the only thing, no, you can have it, you had it here, no? That was possible, that's what. Yes, there will be 2 points, that is what I told you. It is yes, you have to mention, it is on either side of both the charges, either side of the charge with lesser magnitude. So 10 is also an answer and 40 is also an answer, but with respect to whom? But with respect to the 5 microcoulomb charge. That you need to mention. Okay, we'll wind up this. Thank you, sir. Yeah. Okay. Okay.